Beneath one of the busiest shipping corridors on Earth, China attempted something almost impossible. Engineers had to sink gigantic tunnel sections beneath the sea, fight unstable geology, powerful estuary currents, and relentless marine pressure, all while building one of the largest transportation systems ever created. This is the real story of how China built the Shenzhen-Zhongshan Link tunnel. Beneath the Pearl River Delta lies one of the most complex construction environments on Earth. To connect Shenzhen and Zhongshan, engineers first had to map an unstable estuary shaped by shifting sediments, deep water channels, and powerful tidal currents that constantly reshape the seabed. Before a single structure could be built, survey vessels traced the entire corridor with centimeter-level precision, marking the future path of what would become the Shenzhen-Zhongshan Link tunnel.
Here at the Shenzhen-Zhongshan Link tunnel, the first challenge isn't concrete or steel, it's water, current, and the unstable seabed below us.
This was not construction yet. It was the creation of an underwater blueprint for one of the largest immersed tunnel systems ever attempted.
收到，开始第一斗，挖掘稳定，后面正常。第一斗完成，转转就位。
Inside engineering control rooms, the invisible foundation of the project took shape. Geological models revealed soft seabed layers, deep compression zones, and unpredictable water movement across the estuary floor. Every meter of the future Shenzhen-Zhongshan Link tunnel was simulated under real-world conditions. Water pressure, sediment shift, and current force, all calculated before construction began.
The Shenzhen-Zhongshan Link tunnel cannot be rushed. Before any tunnel section arrives, the seabed trench must be shaped, checked, and corrected again.
Engineers weren't just designing a tunnel, they were predicting how the ocean itself would behave during construction. What followed was one of the most detailed underwater infrastructure plans ever developed in modern engineering history.
At night, the Shenzhen-Zhongshan Link tunnel team does not speed up. They reduce the work zone, add floodlights, and the control. The Shenzhen-Zhongshan Link tunnel artificial island cannot be built all at once. This new ground has to settle, compact, and stabilize before heavier construction can begin.
At the fabrication yards, the first physical reality of the Shenzhen-Zhongshan Link tunnel began to take form. Massive immersed tunnel sections were constructed like giant concrete vessels, each one built in controlled dry docks with precision reinforcement, waterproof sealing systems, and embedded structural networks.
The Shenzhen-Zhongshan Link tunnel sections are built here on land first because underwater construction at this scale would be far too dangerous and inaccurate.
Every segment was engineered to float, sink, and align underwater with millimeter accuracy. These structures would eventually be transported across open water, lowered into the seabed trench, and joined beneath the estuary floor, forming a continuous underwater highway between two major cities. This is where construction truly begins, on land, before it ever reaches the sea.
Even though the Shenzhen-Zhongshan Link tunnel sections are made from enormous amounts of reinforced concrete, they are engineered to float temporarily during transport across the estuary.
Ballast system stable. Pump cycling. Flow rates nominal. Emergency controls verified. Open floodgates. Gates open. Test channels flowing. Tide window is tight.
Once fabrication is complete, the Shenzhen-Zhongshan Link tunnel sections are no longer static structures. They become floating engineered systems. Each massive tunnel unit is carefully sealed, floated out of the dry dock, and transferred into open estuary water using a tightly coordinated network of tugboats and ballast controls. This phase is extremely sensitive. The structure behaves like a controlled ship, but with the weight of a building and the precision of a surgical instrument. Every movement is monitored in real time as engineers prepare for the most dangerous step ahead, transporting these enormous sections across open water toward their underwater installation zone.
Profile is stable. Trench alignment is green. Good. Initiate controlled sinking. Monitor cables. Cables and comms are checked. Ready for descent. Copy. Proceed with alignment. Depth at 38.
Copy. Solar is stable.
Current shift. Pumps in ballast.
Adjusting lateral trim to 0.5 degrees.
Increase cable tension.
The Shenzhen-Zhongshan Link tunnel section is being lowered with centimeter-level accuracy, even though most of the operation is happening underwater and out of direct sight.
With the first section in place, additional segments are transported and lowered into position. Each new segment must align perfectly with the previous one underwater, where visibility is near zero and precision relies entirely on sonar and guidance systems. Engineers control millimeter-level adjustments using cable tension and ballast redistribution.
Alignment readings are stable. Let's check the ballast systems.
Sealing system integrity is confirmed. Tolerance to smash the seabed section.
Good. Update the float out sequence.
Confirmed. Releasing the report.
Once aligned, the sections are mechanically locked and sealed using watertight joint systems. Pressure equalization follows to ensure structural stability. Step by step, the tunnel becomes a continuous underwater corridor beneath the estuary.
Joining the Shenzhen-Zhongshan Link tunnel sections underwater is like connecting giant floating buildings with almost no visibility and virtually no room for alignment error.
Inside the completed tunnel segments, construction continues on the operational systems. Roadway slabs are poured, drainage systems are installed, and ventilation ducts are suspended across the ceiling.
Inside the Shenzhen-Zhongshan Link tunnel, engineers are now building the systems that will control airflow, lighting, drainage, emergency response, and long-term tunnel safety.
Electrical networks, monitoring systems, and communication lines are routed through service corridors. Emergency evacuation paths and fire suppression systems are built into the structure. Every system must function under extreme conditions of pressure, moisture, and long-term marine exposure. This phase transforms the tunnel from a shell into a fully functional transportation system. Before opening, the entire Shenzhen-Zhongshan Link tunnel undergoes rigorous testing. Engineers simulate traffic loads, airflow pressure, fire scenarios, and emergency evacuations. Ventilation systems are pushed to maximum capacity, while structural sensors monitor stress across submerged sections. Water ingress checks confirm sealing integrity. Control systems are synchronized across the full network.
The Shenzhen-Zhongshan Link tunnel now connects massive sections of the Pearl River Delta through one of the most complex underwater transportation systems ever constructed.
This phase ensures that every component performs correctly under real-world conditions before the public is allowed inside. The Shenzhen-Zhongshan Link tunnel is now fully operational. Vehicles move continuously between Shenzhen and Zhongshan through a seamless network of bridges, artificial islands, and underwater tunnels. Marine traffic continues above, unaffected by the infrastructure below. Control centers monitor every movement in real time, ensuring safety and efficiency across the system. What once was open water is now a permanent transportation corridor, reshaping regional connectivity across the Pearl River Delta.